Yes, welcome to my presentation about distributed HTTP caching in cloud-native environments. I will try to mention about how we can implement caching in cloud-native in an easy way, not the usual way. Firstly, let me introduce myself. My name is Alparslan Avci, and I'm working for Hazelcast for more than 4 years. Actually, I started working as a solution architect, and then I'm now as a software developer, actually a Java developer. And now I'm currently working on integration modules most of the time. And I like to solve problems if I can, sure. And you can always access me or reach me using my email. It's alparslan@hazelcast.com. Yes, let's start with some definitions, microservices. Let's make a book definition of microservices. Microservices are a software development technique, a variant of the service-oriented architecture, SOA, architectural style, that structures an application as a collection of loosely coupled services in a microservice architecture. Services are fine-grained, and the protocols are lightweight. The benefit of decomposing an application into different smaller services is that it improves modularity. This makes an application easier to understand, develop, test, and become more resilient to REST architecture erosion. It parallels development by enabling autonomous developers deploy and scale their respective services independently. It also allows the architecture of an individual service to emerge through continuous refactoring. Microservice-based architectures facilitate continuous development and deployment. Another definition. Yes, I'm kidding. I won't continue with the definitions, surely. This won't be that much boring, maybe a little, but not that much. Let's meet our friend, Clark Kest. Clark Kest is a humble developer. He is working for a small company, a startup company maybe, and he likes to be a simple guy. He would like to develop software in an easy way, not in a complicated way, because he would like to spare some time for coffee and playing for PlayStation maybe. I don't know. One day when he was working for his company, he met a guy. This guy. His name is Dr. Waterfall. It's a crazy developer, crazy scientist, maybe, I know. And this Dr. Waterfall developed an application for a solution as a project. And it developed it as a monolith application. It's a giant application running on a single dedicated server, maybe. I don't know. But there are some issues with this monolith application, as you know, actually. Firstly, it was too large and complex to manage because it is providing all the features in a single application. And it's also difficult to scale because especially since it is providing multiple features in it, you cannot horizontally scale it like a distributed application. And also, it has a slow startup time because most likely it is using many different resources, maybe doing some I/O operations at the same time. So it is really difficult to start up in a fast way. And also, it should be redeployed wholly on each update because you cannot do small changes, just a single part of it, and so on. As you all know about monolithic applications. So Clark Kest should do something about it, but not as a Clark Kest. He has a secret identity. Meet this superhero, Hazel-man. Actually, Hazel-man, as you can see, with his fancy outfit, actually he has many superpowers, like being a super agile developer, and he likes to develop applications in an agile way. He's also a simple guy. He doesn't want to do many things when he's working. By the way, H in the outfit is not for Hope, it's for Hazelcast. And as you all know, with great power comes great responsibility. And to deal with monolithic application, Hazel-man took his sword of granularity. This is the sword of granularity, this one here, you can see it. And he cut the monolith into microservices. Here he comes, and he cut the monolith application into small, cute microservices, and Dr. Waterfall runs away. So then after that, after building microservices, he moved them to the land of cloud native. So in a cloud native environment, microservices are living much happier. So they are now modular, easy to manage because they are in smaller independent applications, and also they are scalable, easily scalable, not just vertically but also horizontally since they are small applications. And they are also open to integration since they are independent to each other. You can integrate it to many other services or even also some microservices. And they are provided in a distributed environment, which comes with the advantage of the distributed environment itself. So they lived happily ever after, or just for a while, right? Not so long, because as you know, living happily ever after is impossible in a software development environment. So what happens? Microservices communicate to each other, as you know, they need to, and also they need to communicate to the clients. They can communicate to each other to share information, and most of the time they are using HTTP for this communication as a protocol because they are mostly using REST APIs. Maybe some other times they can use other different protocols also. And some microservices can be running very slow because there might be some compute-intensive operations, or there might be some data processing inside, or any other thing. There might be heavyweight applications, and they can be also using many other resources or other microservices or some other external services at each time when they are accessed. And some of them might be mostly read-only. You don't need to, you just read the data, and the data might be static most of the time. So this can be some trouble in a service mesh environment. Firstly, it comes with more complexity because you need to figure out the problems, so you need to add more complexity. And the service you are providing might perform perform less than the expected one, and the availability may be less, and there can be also some high dependency. So Hazel-man is needed again. Hazel-man's greatest superpower is he knows how to use Hazelcast IMDG. So what's Hazelcast IMDG? Actually, it's a full-featured in-memory data grid. We can say it in-memory data platform. It provides lots of in-memory data structures, such as maps, such as queues, lists, topics, and other things. And also, actually, it is mostly used for caching, and it is also a fully compliant JCache provider. It's also an open-source platform with Apache 2 license, so you can do anything on the source code. You can change it, or you can use it on a commercially without paying anything. And it's also a small jar with minimal dependencies, which you don't need to install a huge server on your environment. And it also supports embedded or client-server topologies, which I will mention in detail a few slides later. and it also provides multi-language client APIs. So Hazel-man will use Hazelcast to add caching to the microservices, right? It will just add the Hazelcast. So firstly, there are two topologies that we can mention when you are using Hazelcast. The first one is the embedded one. You can use Hazelcast as a dependency to your application. When we are talking about microservices here, let's call microservices. You can add Hazelcast as a dependency to your microservice. And then when you start your microservice, the Hazelcast members can communicate to each other and build a cluster and share the data, the in-memory data, between these microservices. So but you need to use Java for this one, since Hazelcast itself is developed as a Java application. You can also use as a client server, so you can create a server, a cluster, using Hazelcast members in a different place, as you can see here. And then you can use Hazelcast client API, which is written in different languages, such as .NET, C++, or Node.js, to reach the cluster, which is set up in another microservice, most likely. So it is very easy to develop microservices using Hazelcast. So just first, let's make a classic demo. So we will do a simple one, not a complicated. I have a simple web application here. It's just a Spring Boot application, and it has a controller, a REST controller. It has a request mapping called greeting. It's taking a parameter, which is called name. And with this name, actually, it's just using this template, the hello.parameter, it's just providing a greeting object, which is just containing a content, nothing else. So to imitate a data intensive operation, I just added here as 3 seconds of thread sleep. So this should take at least 3 seconds when it's running. So how we will be implementing this one on a cloud native environment? We will use a Docker container. Firstly, we will use Alpine as a page image, and then use our implemented jar file. And as an entry point, we will run our jar file with the server port as 80. So it is open to do all HTTP requests by default when we deploy it. And I already uploaded this to my own Docker Hub. As you can see here, it's here actually. Don't worry, this is the same application. I didn't change anything on this one. So to deploy it on our cloud native environment, which I will be using Minikube in my local, actually, yes, this, as you can see, there is a deployment configuration with 2 replicas. There will be 2 pods running on our Minikube. And then our greet application will have the container, which is the images getting from my own Docker Hub repository, and the container port will be set as 80. And there will be a load balancer service, which will be accessing to our greet application, again, using the 80 as the port. So let's try and firstly check if our Minikube is working. Yes, it's working. And we have no pods running right now. And let's apply our configuration. So the greet deployment has been created, and then the service has been created. Let's check the pods. Yes, there are 2 pods as we configured it, and let's also check for services. Yes, our application is running this external port, so we can use this port to access to our small application. I will use CURL. Firstly, I will also check the Minicube's IP. Yes, this is running here. So using CURL. Oops. Yes, and using this port here, I will reach to the mapping, and I will use name as, for instance, Devoxx. So when I put on enter, as you can see, it's waiting to complete the data intensive application, which we imitated by using thread sleep. And the response is, we get the response as hello Devoxx. And when we call it again, it's again doing the same operation and doing the same data intensive application. Anytime we call it, we will get this long running application. So how we can add a simple cache, actually it's simple distributed cache to this application. Let me close these ones. Firstly, it will be nearly similar, but let's first start our dependencies. I will add Hazelcast as a dependency, as you can see here. I'm adding the beta version on which will be coming, which has been used actually already. And this is actually, again, a Spring Boot application, but I add the enable caching annotation as a configuration to let Spring to use caching. And I just add some configuration parameters. So the Spring framework will use a bean, which is a cache manager, which is created as a Hazelcast cache manager. This is actually comes with Hazelcast all package. This is generated for Hazelcast Spring integration. And as you can see here, it is just using starting a single Hazelcast instance. So each time we create this application, it will create a Hazelcast instance as an embedded way. And we also need to change the greeting, and we need to add this serializable interface. Actually, we need to make it serializable in a way. I'm using the default Java serializable interface. Since Hazelcast is a distributed cluster and it will share the data among its members, we need to make the greeting object serializable to make it transmittable. And after that, on the greeting controller, I just add the cacheable annotation to my request mapping. So this request mapping this cacheable will use names cache, actual names map on Hazelcast side to cache the results of this greeting request mapping. It will use the name as the key and the greeting object as the result, as the value when it is caching it's on Hazelcast cluster. So the Docker file will be the same. We don't change anything. And let's firstly kill, sorry, I need to change the deployment. Now it will be cached greet. Again, cached greet is this is already in my repository. So I add a cached grid here. Let's first kill everything what we run. Sorry, wrong button. Yes, let's check if it's ending running. Yes, on its Kubernetes cluster. Let's deploy it again. And let's check if our pods are, yes, it's creating the container. Yes, both of them are running. Let's check the logs of these containers. What do they contain? Let's just pick one of them. yeah, you can see that it is running right now. Sorry. It created a Hazelcast cluster with single instance. Let's check again. Yes, after a while, actually after a small time amount, they built a cluster with 2 members. Since there are 2 pods, there will be 2 Hazelcast members, which is building a 2-member Hazelcast cluster in the end. And let's call our services, and let's see which is the IP, port. And let's change our port with the new one. And for now, I will again calling Devoxx. Yes, the first time when we call the same request mapping, actually it takes again some time because the first one was the cache miss. We don't have the result in the cache, so it was a cache miss. Now, if I call it again, it's coming instantly because it's now coming from, as a cache hit, it's coming from Hazelcast maps. And if I call it again, it's coming instantly. If I change it to another, for instance, another name, it's the first time is a cache miss, the second one is a cache hit. So right now, my application is cached actually in Hazelcast cluster. So everything's okay, right? It's working all okay, but there are some problems, especially when you increase the number of microservices in your environment. For instance, if you have tens of microservices in your environment, if you would like to add caching to your microservices, that might be a problem because, yes, we did just a small amount of coding in our application, but imagine that you have 80 or 100 or maybe 200 microservices in your environment, and you need to provide specific caches to each of these microservices. It will be difficult to manage actually. So you need to change all of the codes, especially if you don't plan to caching in the beginning of your application design. That will be really difficult. Even after the implementation, sorry, I don't know what happens. Yes, sorry about the interruption. Yes, even after the implementation, the updates can be a real pain because you need to know each details for each caches that you implemented. So it can be a problem. So what should our hero do to resolve this problem? Suddenly, something appeared in the sky, a cloud. In this cloud, we see a picture. This is Master Talib. Actually, it's the founder of Hazelcast, and actually he's the inventor of Hazelcast. And he gave a clue to our superhero, use sidecar pattern. And our hero, yes, we found the solution. What's sidecar pattern? Actually, sidecar pattern can be used on different environments, but when we think about cloud native applications, it's mostly used in the Kubernetes pods, because since we can provide multiple containers in Kubernetes pods, you can use sidecar pattern when you are developing your microservices. The first container will be your main application, and the second container will be providing some side applications, such as caching, logging, some security applications, maybe some filtering applications that might be. And most of the time, we are using proxies to communicate between these two containers. And so how will Hazel-man apply the sidecar pattern to our application? So firstly, we will have our regular microservice without any caching. Imagine that we haven't implemented any cache. And then we will have a caching proxy application, which is using Hazelcast IMDG. And then we will have some forwarding on the network layer. So the request will come to the Ethernet interface to 80 ports, and our forwarding will forward it to from 80 port to 8000 port. The Hazelcast IMDG caching proxy application will listen at 8000, and it will check if the cache exists, if it's a cache hit or miss. If it's a miss, then it will forward the request to the loopback, and which the loopback is actually with our microservice, the main microservice application is listening from loopback at 80 port. So the microservice application won't know anything about caching by this implementation. It will work as transparently to the caching layer. This layer will be separated from the microservice. And if there will be a cache hit, of course, it won't. The caching proxy won't forward the request to the loopback. Instead, it will return the response to the original client. So let's make the demo for this one. First, let's close all of them and let's kill our deployment. Yep. So we will use similar things. Firstly, we won't touch anything to our initial web application. This will be using the same greet application without adding any serialization to our greeting object. So this will keep the same. For forwarding the request at the network layer, we will be using a simple shell scripting. I will use iptables command to forward it as a net service, and then we will get the request from Ethernet interface at the port 80 and redirect them to the 8000. So, and then this will be the Docker file for this one. This will be our first container. It will be using Ubuntu latest as the base image, and then we will be copying our SH script to shell script to the bin directory, giving the required permissions, and providing the enter point as the script. So it is a simple one. And for the proxy application, it will be again a Spring Boot application, a similar one. Sorry. And for now, for this one, we will be having a greeting controller. As you can see, it is starting a Hazelcast instance for each time. And the Hazelcast instance is using a Kubernetes config. It allows Hazelcast to build a cluster between Hazelcast pods in an easy way. So it will use it. And now we have a request mapping for all the servlet paths. So for this one, we are creating a URL which we will forward the request to the local host loopback at 80 port. We are using the servlet path of the request, and we are getting the query string. So this URL, this new URL, will be the key for our cache, the proxy cache. So we are using another cache on Hazelcast. It's just a cache. And for this one, we are checking if this URL is already exists in the Hazelcast cache. So if it exists, then it's a cache hit. Then we just return the URL's the value of the key value entry. And if it doesn't exist on the cache, then we use a REST client to call the URL to our base application, base microservice, and we put the response to our cache, and we return the response again. So it's another one, easy one. The Docker file will be the same, just the server port will be 8000. And for the everything happens in the deployment when we are deploying on the cloud native environment. So again, we will have 2 replicas, 2 pods running on the Kubernetes environment, and our application will be great again. But this time, we will have 3 containers in our pod. The first container will be our init networking. Again, it is taking the networking from my own repository, and it is adding some capabilities since it will changing the networking. And then we will have 2 more containers. The first one will be our caching proxy application, which the container port will be 8000, and we will have our regular microservice application, which will be running on container port 80. And our load balancer will be, again, listening on 80. So let's work on this one. Firstly, let's check if anything is working again. Yes, nothing is working. So yes, I now applied this configuration to my Kubernetes environment, and let's check for the pods. Both of them are initialized, and both of them are running right now. Let's check the services. The load balancer is up, and let's check the logs again. What do we have? Let's check one of them. Now we have multiple containers in this pod, so we need to provide a container name. Let's check for the greet application first. Yes, as you can see, it started as a simple Spring application, Spring Boot application, and it doesn't know anything about Hazelcast itself. And let's check what we have on the caching proxy. Yes, on caching proxy, you can see that it is running a 2-member Hazelcast cluster. It built the cluster itself. So the caching layer separated from the microservice itself. So let's try to run our application. Sorry. First time, again, it will be a cache miss. But when I run the second one, it will come instantly. So we separated the layer, the caching layer, from our microservice. If we try with Devoxx again, the first one will be cache miss, the second one will be a cache hit. So it is running with cache right now. So what are the advantages and disadvantages of this approach? Firstly, no code change is required. As you can see, for our main application, we didn't change anything. We just used our old application, and it is actually programming language agnostic. So you can use any application developed in under any language with this pattern. And as we said, actually, the caching is now working on a separate layer. But there are some disadvantages, as you can imagine. Firstly, the invalidation configuration will be difficult on caching layer because right now we will have the same cache for all the microservice applications. So if we would like to provide different business requirements to our cache, which the invalidation most likely depends on the business requirements, so we need to work on it more to provide a good invalidation. And also, it will be based on single protocol because our caching proxy will be running on HTTP. If you would like to use multiple protocols, you need to work on the caching proxy application. And another thing is actually, most likely you have heard of Envoy, Istio, and the other proxy solutions on service mesh. Actually, there are no mature solution for caching on the proxy level for now. Actually, Hazelcast, we are working on Hazelcast actually. We would like to implement a caching proxy, a mature caching proxy, but there is none right now. The one that I used here is just actually a non-production ready one. As you can see, it is just using a simple REST client, and also it is using a simple way to do the cache miss and cache hit operations. So now they can live happily ever after, right? Or maybe just dream about it, because it's no way to live happily ever after in a software development environment. So yeah, that's all from my presentation. If you have any questions. It was a super easy one. Because of that, you are not asking anything. Just a disclaimer, Hazel-man's powers don't arise from the outfit he is wearing. Actually, you can have his powers by visiting hazelcast.org documentation. It's the official documentation of Hazelcast, and also from hazelcast.org get involved page, you can have all different community pages. Thank you for joining my presentation talk.